Hello, Joro, you're on mute.
Hi everyone, welcome to Azure User Group Sweden. Hi Okan, welcome. Thank you for reminding me that I was on mute. Yes.
Hello, and welcome to everyone watching this either live or watching this in the recorded session.
Yes, I'm Jonah Anderson. I'm a Microsoft MVP for Azure and also a software engineer. And here with me, we have Håkan.
Yeah, so I'm Håkan Silvernagel. I'm also Microsoft MVP in artificial intelligence, and I work as a consultant for a Norwegian consultancy company called Miles.
All right, and before today we have an awesome session and from a great speaker. But before we get started, let's show our viewers our code of conduct.
Yes. Yeah, so basically in our code of conduct, we put the emphasis here that it should be a safe place here, that we should be nice and friendly, we should listen with purpose and be thoughtful, and we need to be respectful to others. And we seek to understand, not to criticize, and we should be curious and open to share ideas. And we should also be inclusive in our comments or questions. And if you want to read our code of conduct, you can find it on the URL here. And also, if you want to know more about our meetup or sign up for our next events, you can do that on the link that we show here.
All right. Yeah, thank you. So without further ado, maybe we should welcome our speaker, John Kilmister, on the stage.
Yes, let's invite him.
Yes.
Hello, John.
Hi, good morning.
Good morning.
Hi, good morning.
So now, John, he is a principal software architect and a software engineer who enjoys exploring new technologies to solve real-world problems. And he has a background at e-commerce companies and currently works as the principal software architect at the UK largest gym called PureGym. And there he works with teams on both web and mobile applications. That sounds interesting. So do you have sort of any specialty within the web and mobile or?
No, so look at a whole range of things, really helping out all the different teams to do what they do. Most of the experience in Azure is around kind of PaaS solutions, so as your web apps and logic apps and things like that.
Mm-hmm. Yes. And I see also on your background that you have some nerd guys behind you. Is it like from? Yeah, it's yes, the smart one, Yoda.
Yeah. Well, that's
Baby Yoda, the Baby Yoda from the series. Yes.
Yeah, you can't see my room is full of Lego models around me. But,
yes. Yeah, it's a good series. I've seen it. So he's a baby, a very smart one. It's good to see. Yeah.
So what will you be presenting today, John?
So today I'm going to talk about a journey that actually I've been on multiple times, which is breaking up huge monolithic custom written websites. And we're going to have a look at firstly what they are. Not everybody's necessarily worked with a software engineering team and seen these. So we have a look at them. We look at the goods and the bad things about them. You know, there are scenarios where you do want a monolithic website. And then once we've kind of looked at that, we'll look at how we tackle breaking that up. And Azure is a big part of that. So we'll look at some load balancers in Azure, look at the 4 different options we have there, go through those and work out which one is the best to tackle this particular challenge. And we'll look at how we go about implementing that. So we'll have a quick demo before looking at finally a few other of the Azure services that can help us solve the problem.
Sounds great. Nice. Yes. So let's give you the stage. The stage is yours, John. Let's see.
Great. Thank you. So as we just said, we're going to be talking about breaking up these monolithic websites. But before we get started, just if you have any questions or want to find me afterwards, you can find me on Twitter at John Kilmister. I also have a blog at blueboxes.co.uk where I show some Azure bits and pieces. And we can see here my Azure certifications as Azure Solution Architect and Azure Developer. So let's get into the main part of the talk. What are we going to cover? Well, as I mentioned, it is important to understand, first of all, what a software monolith actually is. So we'll take a look at that. We'll then look at a number of load balancing and routing options, starting with some theory, then going into the Azure services. And finally, we're going to finish up with the additional Azure services that we can use to solve some of the problems that we're going to be talking about in the early part of the presentation. So let's start right at the beginning. What is a monolith? Well, this is a monolith. You might remember this. It was placed in the Utah desert back in 2016. It's not the type of monolith we're going to be talking about today, but it's good to understand what is meant by a monolith. And in this case, a monolith is a single solid block of metal in this case, but monoliths can be stone and various other bits and pieces. So how does that relate to a software monolith? Well, a software monolith, all of the layers of the application are coded, managed, and then deployed together as one single block. So unlike a microservices architecture, where you have lots of different components that all have to talk to each other, in a monolithic application, everything is all together. It's all source code together. It's all deployed together. And we'll look at this a lot more throughout this talk. But the first question to answer is this a good thing or a bad thing? Should we always avoid monoliths in every situation? Well, the answer is a bit complicated. Monoliths can actually be a good thing. If you have everything in one place, you know where to go and make your changes. If it's all in one deploy, you don't have large amounts of infrastructure to manage. And if you need to scale it, there's only one thing you need to go and scale. But on the flip side, monoliths can start to have some challenges. And over time, especially with large and complex systems, they can quickly get into what can be seen as a big ball of mud or spaghetti code where everything kind of talks to everything else and it's all tangled up together. So a lot of the advantages that you have when you've got a small monolith actually become its weakness when you get to a monolith at scale. Let's take an example. This is an e-commerce website. It has three simple features. We have a product catalog, we have a shopping cart, and we have our final checkout. And we've hired 3 engineers to work on this. And all's going well. It's all nice in one code repository. We can ship that to a single place in Azure. But we need to put more features in. And these 3 engineers, they're taking a little bit of time to get stuff done. So we hire 3 more engineers, twice as much engineers. Maybe this is a way to get twice as much throughput. But they're all contributing to this same block of code. And they start stepping on each other's toes a little bit as they add in new features. And we can only deploy it all together at once. Even a single line change requires us to run our automation tests across the entire solution because we don't know what impact that's going to have. And then when we need to deploy it, we've only got one piece of infrastructure out there, so we have to deploy it all at once. But with 6 engineers, it's not working out too bad, and we're adding in a few extra features here and there. But things start to slow down as people find it hard to find bits of code. So we hire more developers. And as you can see, we're starting to put more and more into this monolith. We have a large number of people working on it. We have a large code base, and it's hard to find things. It's now no longer possible for one person to understand the entire code base. And then we've got a bottleneck in our flow. We only have one resource to actually push to in Azure. So how do we go about deploying this? Well, we've got 2 options. We can either each engineer, they finishes a feature and they have to queue up behind the next person in order to send the features out one by one into our production system. But that's going to cause a bottleneck. there's only so many hours in the day. And if you have more engineers and it takes, you know, half an hour to do a deploy, and that's probably quite generous, you'll end up with a long queue and you'll never be able to get all of your features released. Or you could bundle them together. And in that scenario, we'll just take all the features and do a deploy once a week or once every so often. But now we're adding risk, because if something goes wrong, which feature caused that problem? And how do we start unpicking it? And how do we find out who wrote that particular feature or line of code? So this is starting to become a problem when we have this monolithic application, everything together in one place. So a quick recap of those problems. We quickly get unmanageable code where it's all tied together and we're not quite sure how everything interacts. We end up with a lack of ownership. If there's a problem with one particular feature, maybe that checkout page, we don't know who to go to, who manages the bugs, who looks after that, which engineer knows about that part of the system. We have high cognitive load, which is just a fancy way of saying that no one person is going to be able to understand everything. And what that means in reality is that when you want to add in a new feature or you want to fix a bug in a particular area, you have to either try and find someone that's recently worked in it, or the engineers have to learn completely new and fresh what happens and how everything works. And at this point, there probably isn't necessarily good documentation and various other bits and pieces. So high cognitive load is a real problem. Then we get all or nothing scalability. Deploying everything just to one Azure resource has its limits. If you run a promotion on a particular product, you have to scale the entire website. And that website might have a blog on it. It might have a help contact area. It might have the checkout and various other bits and pieces. But we're only running a promotion on one little part of the website. So we're really stuck. We have to scale the entire website, which can be quite costly, or you don't scale anything and you run the risk of having some challenges. And finally, we have this challenge of the deploy congestion that I referred to. You either get everybody queuing up to deploy their feature, or you bundle it all together and you increase the risk. So these challenges are real and can have a big impact on the team. This is a tweet that I saw a little while ago. I'm not sure where the original slide came from, but it talks about the cycle of product death. And we start with a large code base, or effectively a monolith. We have the brain overflow, which is that high cognitive load. And because of that, you end up with silos of knowledge. So some of those people in the team will have worked on some areas and they'll know about that more than other people. So no one person can know everything. So you have to have these silos. And then you have elephant traps, and that leads to failed deploys, and that leads to more project management and Gantt charts, and things start slowing down, and then people leave and customers leave. And it's a bit of a sort of a downward death spiral. But all is not lost. It can be resolved, and that's what we're really going to talk about here today. How do we overcome these challenges, though? This is a big challenge, and we probably didn't get here overnight. So when we talk about these monoliths at scale, very few people will sit down and go, we need to build a website that's going to be managed by 50 engineers, so let's build a monolith. More realistically, you start out with a small goal and you start out with a small team, and we add in people and we add in features, and it's easier to add them into a monolith that you already have than to design new solutions that require new infrastructure and bits and pieces. So it's taken a long time to get here, maybe 3 years, maybe 5 years, maybe even longer, in some cases 10 or 15 years. So we're not going to be able to fix this overnight. It's also worth identifying this isn't just a software problem. There are really 3 areas that we need to tackle. The first one is people and team, and we'll take a bit more of a look at that in a minute. We obviously need to tackle the software. We are talking about a software monolith at this point. But one of the areas that I want to highlight is the infrastructure, and how actually the infrastructure teams, or the infrastructure that we can use, can really help solve this problem. And that's going to be the focus of the second half of this talk, as we dive into Azure and look at load balancing options and routing that can help us resolve a lot of these challenges. But before we go off and look at Azure, let's focus on the people and the team aspect. So there's this theory called Conway's Law, and what it says is that the systems that we have, be they software systems or other systems, are going to mirror communication structures. So if we have one big software engineering team, as we saw in the previous example, you are going to end up with one giant monolithic system. And if you have a front-end team and a back-end team, you're more likely going to end up with two monolithic systems. So we have to think about the people element of it and the way the teams interact as much as we do the software and the infrastructure. And you can have the best of intentions, even with a big team like this, where people kind of leave, do a project, and then come back and they're still part of this big team. Without any real ownership, when you come to build your next feature, even if you decide that you are going to pull it out and put it in a separate service, it's very easy to fall back into, actually it's easier just to add it into the monolith. And if we have more distributed teams that talk to each other like this, we naturally get software systems that talk to each other like this. And if we have separate teams, those separate teams have ownership of part of the system, and they will want to isolate that from the other parts of the system so they can truly own it, truly understand all of those. Now, this talk is mainly going to focus on Azure and the Azure infrastructure. But if you are interested in the people side of it, and it is a big part of the puzzle, I'd recommend going and having a look at the Team Topologies book by Matthew Skelton. In that, he talks about how we can design organizational structures with different team types. So things like stream aligned teams, aligning them to business units, enabling teams that are there to assist and help other teams, complicated subsystems and platform teams. So it's a really good book, Team Topologies, and I'd definitely recommend going and having a look if you are interested in learning more about that side of things. While we're talking about teams, the Accelerate book is also a very good one that talks about how we can build high-performing, high-scalable technology organizations. So also well worth a look. So let's get back now to the second part, is the software. Obviously, a big part of this was talking about software monoliths. And there are many considerations. But what about just sweeping it all aside and starting again? Well, that can be very tempting and can be something that actually the engineers really want to do. They don't like working with this monolith. It's hard to find anything. It's hard to understand anything. So why don't we just knock the entire thing down and build a fresh system? Well, as I mentioned, this is years of work, maybe 5 years worth of work. It's going to be hard to get buy-in from the wider organization to say, this thing that we've got, we're not delivering as fast as you want us to because it's a monolith and it's causing us challenges. Could we put it to one side and spend a year, maybe 2 years, rebuilding the entire system? And at the end of it, you're going to have the same feature set that you have now, but it's going to be easier to develop new features on top of that. And while we're developing it and you're not getting any new features, we're going to probably cause a little bit of disruption to the organization as we question why and how we do things. And that's going to be really hard to sell. And even if you do sell it, it's hard to keep the momentum going over that long period of time in order to build out the new system. And when building systems, you often want to take an MVP approach and do things incrementally. If you think of a city, I can't think of a scenario where they ask all the residents to leave. We just bulldoze the entire city, wait a couple of years to rebuild it, and then we move everyone back in. That's not how we would do it if it was a physical set of buildings. So why is it that we consider this when we're looking at software? So if we're not going to knock it all down, what should we do? Well, much like this cake, it might seem like a good idea to eat the whole thing in one go. Going one slice at a time is definitely more manageable, and we can get more buy-in, and we can do things a little bit at a time, and it is much nicer. As I mentioned, there is a third piece to this, and this is going to be our focus for the rest of the talk, and that is the infrastructure. And it's really important for the infrastructure teams to understand that the software and the people are a part of this, but there's a really big role for infrastructure to play. This brings us on to routing and load balancing. And before we go into the Azure side of things, I just want to do a bit of a recap on some theory. There are two core types of load balancer. This is a first type of load balancer, and it's called a layer 4 load balancer, and it's working at the transport layer. What's happening here is that the user is accessing our website, and then we're sharing the traffic between 3 different database servers. And it's all happening with the network packets. So the data comes in, and it's just evenly distributed amongst the 3 servers. It's not particularly intelligent. It will just send them to one of the 3 servers. In a layer 4 load balancer, we don't have as many options because we can't look inside those packets at the actual data. So that brings us on to a layer 7 load balancer. Now, a layer 7 load balancer works at the application layer. So it can actually look inside those packets and make intelligent decisions on them. So in this case, the user is coming to the load balancer. It's then routing the traffic to one of 3 web servers. It could be routing it on a round robin, just send data to each one. But we can actually be more intelligent with a layer 7 load balancer. And we can say, based on the URL, send it to this particular server, or based on a HTTP header, or anything else that the application has, we can route the traffic intelligently on that. And the layer 7 load balancer is the one that's going to help us with our particular challenge that we have. Now, before I move on, I do just want to quickly point out that the load balancer sat here in the network is marked as an internal load balancer, while this one is a public load balancer. Now, either could be layer 7 or layer 4. It's just that the public load balancer is directly interacted with by the end user, where the internal one is part of our internal infrastructure. And it's these internal load balancers. We have a lot of these in Azure already. When you have an Azure web app and you scale it to 2 instances, for example, there'll be an internal load balancer there distributing that traffic. So I just wanted to highlight that before we moved on. But let's get back to our monolith. So our monolith here, the user accesses the website. This website has in it the API, the website, the user interface, everything is in one deployed unit. And we need to start breaking this up. The obvious thing to do is to break up the back end into microservices. And this is quite well known and understood. And it is transparent to the end user. We get our website to point to our new product API, and the different part of the website to the shopping cart API, and so on and so forth. And we start to tackle some of the problems this way because the product API can be independently scaled and it'll be deployed independently from everything else. However, we still have this monolithic website that all of the different teams need to interact with. So what can we do about that? Well, we could split that up into separate websites. And you do occasionally see this. And you can see here that we have to put different subdomains so people can get to those different parts of the websites. But the challenge with this approach is that, well, our monolithic website has been around for 5 years, say, and we've built up lots of links that come into that website. So from an SEO perspective, or links in emails. So we don't want to go and change the URL structure. Also, this is confusing for the user. And yeah, it could be problematic. Really, the user doesn't care about the fact that we have a monolith or we don't. They care about being able just to access a single website that looks and feels like one cohesive product. And this is where our layer 7 load balancer can come in. So based on the URL, we can actually, behind the scenes, redirect traffic to the individual places. So if they come in /products, it's going to go to the product pages. It's going to go to the shopping cart, they go to /cart, so on and so forth. So we can keep our existing URLs. We can keep the customer experience the same. However, behind the scenes, we can break things up. And this means that we no longer have an unmanageable code base. We don't have a high cognitive load, because each of those vertical slices could be owned by a separate team, and they just have to understand their vertical slice. We don't have deploy congestion or scalability issues, because each vertical slice is completely independent. And no longer do we have lack of ownership, because we can now assign each of these vertical slices to different teams. So that's the theory. Now let's have a look at the options in Azure. So there are 4 different routing and load balancing options. The first one is Traffic Manager. Now, Traffic Manager is a routing option as opposed to a load balancer, and it's all based around DNS. The user makes a request and it returns the IP address of a server, which are then routed to. So you can set that based on priority or weighted or performance, but because it works at DNS, it can't look at the URLs, and therefore it's not going to help us in our scenario. The first load balancer we're looking at in Azure is the Azure load balancer, but this is working at layer 4, so TCP and UDP. So our routing options are really limited. It's mainly based around a hashing algorithm that will evenly distribute the traffic between the servers. The third option is our Azure Application Gateway, and this works at layer 7. So we can look at the URLs as well as using things like latency, priority, and various other bits and pieces. The challenge with this particular load balancer, however, is that it is regional. So it's going to sit inside an Azure region. And that means for things like high availability or disaster recovery, it might not be suitable. So if a region goes down, so does your entire website. Now you can pair the Azure Application Gateway with a traffic manager. The traffic manager is global and can point to a application gateway in one region or a different application gateway in another region. However, Front Door gives us that automatically. So Front Door is a layer 7 load balancer working at the application layer. However, it is also global. So it sits outside of the individual regions and can load balance between regions quite nicely. So that is the solution really to this particular problem. We need the layer 7 URL routing, and we need it to be global for high availability. So how does Front Door work? Well, you initially put it in and route all your traffic to your monolith. And then at this point, it doesn't give you a huge benefit. There are some features you get with Front Door, but it's setting the foundation. What we can do is we can pull out part of that monolith into a separate website. So here we put all of the blog into a storage account. And if the user goes to anything that's /blog, it redirects them to that separate storage account. And over time, we can pull out other parts. And you have the option. You can either pull the code out of the monolith, or you can do a greenfield build and completely rewrite that particular part of the website. And you can use different technologies. We don't have to stick to one particular language or one particular deployment mechanism. And this means that you can use the best tools for the job. And inside these individual individual parts of the system, we can also load balance inside that. So you can see the cart there is actually made up of 2 web servers in 2 different regions. And finally, we can move out the checkout. But our ultimate aim is to be able to do this very final step of removing our monolith. And we can do this over time in small little projects. So we're taking it slice by slice. Now, front door has 3 different SKUs in the Azure. We have just front door, which is the first one that they came out with. And more recently, we have front door standard and front door premium, both of which in preview. Front door has lots of features. We had a look at how we use it to do routing, but it's worth noting that it supports secure origins with private links. So those back-end servers that are behind front door, you can secure them so they can only be accessed through front door. We get SSL offload. So the SSL terminates at front door, and we can use different SSL certs for the communication between the front door and the back-end servers. Front door can also provide you a managed SSL as well for your application. We get a web application firewall. We get a built-in CDN and compression. We can also add in things like you get basic DDoS protection, and we can add in threat protection as well. The items you see in black here are what are provided by the standard SKU, and the items in blue are the ones that are provided as part of the premium SKU. So how do we go about configuring it? We've seen the theory, but how does it actually work? Well, the configuration is made up of 3 core parts: the front-end domains, so the domain name that you want to be accessing this on; the back-end pools, which are the individual sites that we saw, so the cart or the blog or whatever; and then most importantly, our routing rules that tie it all together. This is where you can say, based on this URL, we will direct the user internally to this particular back-end pool. Now, the configuration screen we're seeing here is from the front door SKU. If we switch across to the preview SKUs, the user interface is slightly different. So we've got domains instead of the front end / domains that we had before, and we have origin groups rather than pools. We still have routes. We also see security as a 4th box, and this just brings up the WAF protection and adds in some additional things like the DDoS and bot protection as well. But both products work in a similar way. You just get slightly more features with the preview configuration, and the names are slightly different. So let's now have a look at an example. I have in the Azure portal, I have here an Azure website, and we're going to see this one is going to be the monolith effectively. And if we have a look at this currently has deployed to it just a sample app that has 2 pages. It has a home page and it has a privacy policy. Nice and simple. And that's just hosted here. And what we're going to do is we're going to look at putting front door in front of this so that we can then switch out the privacy page. So to get to front door, we can just search front door in here, and you can see we have the 2 options. We have the front door, and then we've got the new front door standard and premium. We'll go into that, and we'll create a new one. So creating a new one, you get many different options, but we're going to do a custom create and step through the process of that. So much like any other resource, you have to select a resource group or create a new resource group. And then we have to give it a name. So I'm going to call this FD Demo 5. And we can select if we want the standard or the premium. And as we saw, the premium gives you all of the additional security features. We can set secrets. We're not going to do that at the moment. It's not essential. And this is the next part is adding in the endpoints. So the first thing to do is to create the URL for the front door instance. So I'm going to call this FD Demo 5 again. And as you can see there, it builds out the full URL. So fddemo5.com Z01 azurefd.net. We can later on add our own domain names in, but to get started, we have to have an Azure FD address. So now we've added that in, and we can see that here, we get the rest of the options. And during the creation process, we need to specify the first origin group. So we're going to have this set as our default group, and this is effectively where we're putting in the monolith. And we add in our origin. So default site and our origin, you can pick here from a whole range of Azure services, or in custom, you can just give it a URL. So we're going to click our app service, and it will quickly load those in, and we can see our app services there. There are options for weight and priority. Now, what that's for is if we add in multiple origins. So that scenario where we want to load balance between two different regions, you can add in multiple servers here. We can also specify health probes and a health probe URL. So it will check these websites in the pool to make sure they're available before sending traffic to them. One thing to note is because Azure Front Door is global, these health probes will be hitting your site from all over the world, and you can get quite a lot of traffic from this. So you might want to change the interval to hit it less often. And there's some load balancing options down here, as I mentioned, if you have multiple hosts in the pool. So we'll click add. We will add in the other pools at a later stage once we've created it. So the final step is to add in the route. So this is going to be our default route, and we have to select a domain. At the moment, we've only got the one domain, and then we select a path or pattern to match, and we're just going to select the everything, so /*. We then need to say that when it matches this pattern, where is it going to go? And we've only got one origin group at the moment, so we're going to direct the traffic there, and we click add. So we're now all good to create it. We have our default origin, which is our monolith, and we have our default route that just says redirect all traffic to that. I'm not going to click create now. Creating a front door does take some time. So I will jump over to one that I created earlier, which is FD demo. So if we look down here and go to the endpoint manager, we get this same view that we were looking at a minute ago. We have our domains, our origin groups, routes, and security. I've added in a custom domain. So in addition to being able to go to FD demo, which I can come up here and I can go to that, it's showing the same website that we had there, exactly the same. We can also go to demo.blueboxes.co.uk and see the same website there. So we've got the website directly to the web app. We're just with the privacy page. We have it on the front door domain, and then we also have it on our own custom domain. In our origin groups, this is the default site we set up. That is there. It's got the one endpoint in, and we have our default route. I've ahead of time added a second pool in now. So I have a single HTML file, and that's saved into our blob storage with the website enabled. I've added that in here. There's nothing else I've set in this pool, just given it a name of privacy site and the URL that's needed. And I've added in another route. Now in this route, I've specified that anything that matches /privacy will get routed to the origin group. And we can see that now. If we navigate to privacy directly on the web app, we get privacy policy. If we do it here on our front door instance, you'll see that it's privacy 2.0. So it's using those routing rules to redirect to the privacy policy. And by doing this, we can slowly tease out parts of the website into separate apps, while the user gets an experience that looks like it's all a single website. And the same works when we put on a custom domain as well. Now, there's lots of other routing options because we are using a layer 7 application load balancer. We don't have to do this based on the URLs. So what I've done is created a new rule here, and rules are applied on top of the routes. So this rule here says that if the device is equal to a mobile, then we're going to add in an additional HTTP header called xmobile and set that to true. This allows the software engineers, by adding in extra headers, to get extra information that they can then make the website display differently. We've also overridden the origin group. So when I apply this rule to the privacy route, if it's a mobile device, we're actually not going to route to the privacy origin group. We're going to just go straight back to the default site. So now we've got a scenario where our mobile users are still seeing the original privacy policy website, while the desktop users are seeing the new one. And we can see that by going into here. And if I bring that up and look at the switching to mobile view here, and if we just quickly do a refresh on this page, we'll see that we now go back to the original privacy policy because it's in mobile view mode. And if we go to the actual document, we'll be able to see on the right hand side here that we have that additional HTTP header, mobile true. If we take it out of mobile view and go and refresh the page again, we'll be able to see here that we don't have that. That header isn't there. So there are lots of other options in these rules. If we add a new rule, the conditions can be based on everything from device type to query strings to request headers, and our actions can do things like setting cache expiries, adding in those extra headers, or changing the origin group. So the layer 7 load balancer gives us so many more options. So that's the end of the demo. What we'll do is we'll go back now and have a look at some of the additional Azure services that we can use. So we talked a lot about splitting this monolith up and creating new little websites that we can use a layer 7 load balancer to redirect to, and those individual sites owned by different teams and different parts of the system. But there are some things that still want to be shared. We still want to give the end user that seamless experience. We want it to look the same and feel the same. And we might have things like application insights applied, and we want a single application insights key used across all of those different apps. So how do we solve that problem? Well, we can use Azure App Configuration. So Azure App Configuration gives us a location that can store a key and a value that all of the apps can read from. Now, when you're breaking up your monolith, you might keep with one giant database in the short term. How do we store that? The connection string is a secret, and we don't necessarily want to put that into Azure App Configuration, because although we want it to be shared, we want it to be stored securely. Well, we can pair Azure App Configuration with Key Vault, and Key Vault can securely store our connection string, and we can use a Key Vault reference that's placed inside Azure App Configuration. And then when one of our front-end apps talks back through to the Azure App Configuration, it will use the Key Vault reference to go and get the connection string and return it all the way back. So this is just one of many services that we can use in Azure to centralize those few things that we want to keep the same across the multiple websites. The other thing is authentication and authorization. You don't want a situation where the user thinks it's one website, but depending on which part they go to, they have to log in again. And there are many third-party services that will help you solve this problem. But in Azure, you have the option of using Azure AD, Enterprise Applications, that can give you that seamless authentication across the multiple websites. Finally, we can use package management as software engineers. So there might be some code blocks that you want to be the same across all of these applications. And the way we do that is we package those shared blocks of code up into an NPM package or a NuGet package or Maven or whatever the appropriate language is. And Azure DevOps can be a private repo for those. So you're probably using NPM packages or NuGet packages quite extensively throughout your applications already. But Azure DevOps allows you to create your is a repository of your own. And these become really important when you have these little websites that you want to start linking together to give a seamless experience. So that brings us kind of to the end of what I wanted to share with you today. We looked at the software monolith, the fact that it's all of the code deployed and managed together, and how that's not always a bad thing. We did, however, then look at what happens when they get to scale and the issues with cognitive load or the scalability and the lack of ownership. We talked about how it was a three-part solution, from the people in the team to the code and the software through to the infrastructure. It was the infrastructure we focused on, looking at how we could split the code into vertical slices using Azure. We talked about the website challenges, the fact we wanted to keep the same URLs, remembering the SEO impact, having a single look and feel. We talked about load balancers, the layer 4 and the layer 7 load balancers, and how the layer 7 load balancer is the one that's going to allow us to split the traffic based on the URL, which is perfect for taking our monolith and breaking it apart into smaller chunks or rewriting parts of it, but still giving a seamless experience for the user. And finally, we had a quick look at the other services that we could use in Azure, things like Azure App Configuration, Key Vault, and the Azure AD. So if you want to have a look at more around the team, I would definitely recommend having a look at the Team Topologies websites and the book and various resources around that. If you want to learn more about the load balancing options that I talked about, Microsoft Learn has some good articles on that, and so does the Microsoft Docs site. And finally, if you're interested in learning more about the preview SKUs of Front Door, there's a good Azure Friday video that covers some of the features that are offered as part of that. So thank you for listening to me today. And as I mentioned before, I have a blog at blueboxes.co.uk, and you can find me on Twitter at John Kilmister. Thank you. And back over now to
Hi. Yes, thank you so much for the great session, John. It was great. I learned a lot. Interesting. Yeah.
I really like the summary slide at the end.
Yeah, that's something I've been trying a bit more sketchnoting recently. I was reading. I was looking to improve my note taking and memorization of bits and things, and I often did find that when I wrote notes, I kind of retained more information. So, and I've been trying drawing since the start of lockdown, just sketching various bits and pieces. So, yeah, it kind of appealed to me to put the two together. It's very early days. I've only done one or two of them, but yeah, it's a good way of taking notes and starting to. It really helped me remember things. And as we're planning out the talk, it also helped kind of modularize it and make sure it had a bit of a flow and a bit of a story to it that it built up over time. So yeah, there's plenty of YouTube videos on how to do sketchnoting if people are interested.
Yes, and I also like that you suggested or recommended some good books about the team topologies and Accelerate. So it's
yeah, so Team Topologies are a really interesting book. We had one giant team, and what we did was we used to take a number of people out of that kind of pool of people to go and do a project, and they'd work on that project for a month, and then they would hand it over to a BAU team, a business as usual team, who would look after bugs and things, and then they would go back into the pool. The problem is that with that approach, you end up like the next project comes along, and say it's another payment project, and those 3 people that did the payment project before aren't available anymore, and you have to pick 3 different people, and they have to go and learn all about payments again, which is quite a specialist area. And I found it hard to kind of verbalize that and look at, well, what is the solution from a team point of view, and get buy-in from our wider organization. And Team Topologies came out right at the time I was starting to look at this. And yeah, I read through the book and could start to find the right vocabulary to describe it to the wider organization. And over the space of a month or 2, I helped redesign the IT department and worked with our wider business colleagues to get buy-in. And it was a really positive experience, and it's worked really well, because that BAU team also was struggling because everybody was handing stuff over to them, and no one really had the time to hand over stuff properly, and they were getting overwhelmed. But now we have teams that own individual slices of things. They really feel ownership of it. It's their responsibility to improve it, to make sure it's monitored and maintained. They have to manage the bugs as well as the new features, but they can work with the stakeholders who are aligned to that team to find the right time to do that. And you can work on longer projects to achieve that. So, but I've written a case study article on the Team Topologies website about my experiences. So I can share the link, and people can have a look at that if they are interested to hear more about that story.
Yes, thank you.
Please share it.
Yeah, yes. We have a few questions from me and Håkan, and also Gabriel, one of our audience. Yes. Let me start. I'll show my question here. So how does Azure Front Door works with serverless architectures, especially those that use Azure Functions?
Yeah, so it works really well, actually.
Great.
I primarily used it for websites that we're routing traffic for the end user, rather than kind of API traffic. But yeah, you get lots of different options in those origin pools. You can directly select different services, but you can also put in URLs. So as long as something's got a public URL, it can route to it.
Great. Next one, Håkan.
Yes, I had a question here. Can you integrate Azure Front Door with Azure API management?
Yes, I believe you can. I've not done it personally, but I do believe that is an option.
Okay. And next question from Gabriel. Does using Azure Front Door will impact latency for the users?
So that is a good question.
Yes.
As soon as you put any additional infrastructure in the flow, it's going to add something. However, if all of your infrastructure is inside Azure, it's routing inside the Azure network, so the latency is negligible.
Thank you. Yes, I think those
also,
are
sorry, it's worth noting with Azure Front Door, you get it is global, so it's going to work with like the closest to the user, and it comes with the CDN, and you get caching options and various other bits and pieces as well. So.
Yes, thank you. Thank you I hope it answers your question, Gabriel. I have additional questions. Like, can you use Azure Front Door with like Azure Monitor and Application Insights? Like, considering that it's like global, it's used global. Like, see who are the users and where they're from globally. Can you implement that well as well?
So, I don't believe that it hooks into Application Insights directly. But it is in Azure Monitor, if I remember correctly. Yes,
okay.
You can. I believe it is in Azure Monitor, but it's not in Application Insights. But I'd have to check. I know it's not something I've used myself.
Yeah, that's interesting because you have your different routes. I mean, routing in different countries or regions, and sometimes as a organization, you want to know where are this traffic's coming from. So that's a random questions that came up. Yes.
Yeah, no, that makes sense.
Yes. No questions so far. Do you have any more questions, Håkan?
No, I don't think so. I think it was a really, really good presentation here.
Yes.
Thank you.
Thank you so
Yeah,
much.
it's a challenge to be able to start breaking up the monolith, and it's kind of, as a software engineer, it's kind of, I just want to start the whole thing again. But time and time again, I've seen cases where we've tried that, and it's hard to get buy-in, hard to put everything down. And I think using a load balancer in this way just means that you can slowly break it apart over a longer period of time, and get buy-in to do that, even if you do it on a 1 page at a time, or you take a whole section of the site. So
Yes, yeah. I have one more thing. Do you have any suggestions or recommendations for learning resources for those developers that want to get started with Azure Front Door?
yeah, so I would definitely recommend looking at the Azure Friday video that covers the features of it. That gives you a general overview. And then there is documentations on the Microsoft site. That's probably the best place to get started.
Yes. Okay. All right. I think we're close to, we have a few minutes on time. Yeah. So I guess that it's time for us to say goodbye soon. Do you have anything else, John and Håkan?
No,
we got some feedback here from Gabriel.
Yeah.
Excellent presentation,
great.
John. Very interesting topics.
Yeah, thank you. And this session is recorded, so you can watch it on demand anytime. So we will be sharing it in our social media, so you can rewatch. Yes. So yeah.
There was one final thing here, just for John. Don't sign off here when we.
Yeah.
We forgot to tell you that in the start.
Yes, you can stay on the backstage. We can do after session talks. Yes. All right. So so it's time for us to say goodbye for now. And thank you, Håkan. Thank you, John. And thank you for the audience. And hope to see you in the next 2 weeks in our next session. Have a great weekend. Bye-bye.